In this section, we're introducing a new type of function that we refer to as exponential functions. The first idea related to this function that we want to talk about is their behavior. What we have graphed in the first graph on the left is the curve y equals x squared. And then in blue, we have graphed y equals 2 to the x. Y equals x squared is a power function. Y equals 2 to the x is an exponential function. In a little bit, we'll talk more about why that is and the structure of those functions. But right now, we just want to focus on the behavior of these two functions and what we can just observe about the graphs. If we look at the right-hand side of each curve, we can see that they're both headed off to positive infinity. So relatively similar behavior on the right-hand side, but on the left-hand side, we see very different behavior. Our power function, y equals x squared, is still headed off to positive infinity. So our function values are still continuing to increase. But our exponential function is getting closer and closer to a function value of 0. And in fact, we refer to that as a horizontal asymptote. This exponential function, as it continues in the direction to the left, will never change to increasing and will never decrease below the x-axis. It'll just keep getting closer and closer to that 0 value. So the behavior on the left for these two functions is quite different. But then we want to shift our perspective and take a look at the graph that we have on the right. Here we have the same two functions being graphed. We've just changed the scale of this graph to see a slightly different picture. The graph on the left only had us going up to x is equal to about 2.5. Now we've changed the graph on the right so that we're up to about x equals 10, 11. So we haven't shifted that x-axis very much, but we're looking a little further up the x-axis. And we start to see very different behavior on the right-hand side of this graph. Both curves are still increasing, headed to infinity, but the graph for our exponential function is approaching positive infinity much faster. And that's a primary difference between power functions or polynomials in general and exponential functions. They can both be increasing, but that rate of increase is much faster. So if you've ever heard the expression exponential growth, something growing exponentially, what we're referring to is this idea of rapid growth. Because exponential functions, their function value increases much faster than, say, something like a power function, y equals x squared.